everyone, it's Justin again. We've been working on translating or writing algebraic expressions. And in our last lesson, we saw that we can use this expression to represent Jake's tree that is 1 foot tall when planted and grows 2 feet per year. 1 plus 2y. This expression represents the height of the tree after y years. But what if I want to know how tall the tree will be after 5 years? How can I figure that out? One plus 2y was the expression used to represent Jake's growing tree that started at 1 foot tall and grows 2 feet every year, which means that this y represents the number of years the tree has been growing. Initially, we wrote this expression without knowing the exact years, hence y. But if we want the height after 5 years, then y becomes 5, or y becomes equal to 5. We can replace this unknown, substituting it with 5, now that we know its value. This is called substitution. Since y equals 5, we replaced y in the expression with 5. It's like a sports substitution. One player leaves and another replaces them. Similarly, y came out and subbed 5 in. Okay. Now we have the expression 1 plus 2 times 5. Notice the 5 in parentheses? It shows multiplication between 2 and 5. Parentheses group things together, but they can also show multiplication, like 2 times 5. All right, so if I can find out what the value of this expression is, or evaluate 1 plus 2 times 5, as we say in math, I'll know how tall the tree will be after 5 years. But how do I do this? Do I add 1 plus 2 first? Or should I multiply 2 times 5 first? Remember when I said that math is a language? Well, just like any language, it requires universally accepted rules for its use. This ensures everyone interprets and communicates with the language consistently. One of the fundamental rules in math is the order of operations. As the name suggests, it directs us to the correct order of various math operations, ensuring that everyone using the math language gets the same answer. Otherwise, if everyone had their own way, math wouldn't be a very effective communication tool. We use the order of operations when we want to evaluate something. That means we want to find the value of it, like the algebraic expressions we've been working with. When evaluating expressions, always start with any operations in grouping symbols first, like parentheses or brackets. Next, address any exponents or powers in the expression. Exponents are numbers written as superscripts, like 2 to the power of 3 or 4 to the power of 2. Afterward, tackle multiplication and division, working from left to right. This means you read the expression from left to right and perform any multiplication or division as they appear. Lastly, work through any subtraction and addition, also from left to right. This doesn't mean you perform subtraction first and then addition, but rather you execute the subtraction and addition as they occur while reading the expression from left to right. As you continue to use the order of operations, it will become instinctive. If you're finding it difficult to remember the order, use the acronym GEMS. Grouping symbols, exponents, multiplication and division, subtraction and addition. Let's apply this rule to Jake's tree expression. Let's evaluate 1 plus 2 times 5. Pause here and evaluate this expression in your PDF using the order of operations we just went over. Let's see. I don't see any grouping symbols, although we have these parentheses around the 5. They aren't actually working as grouping symbols here because they're not grouping more than one thing together. They are just showing multiplication between 2 and 5, like we talked about before. I don't see any exponents. And next up is multiplication and division. That means I'll do 2 times 5 first, and that gives me 10. After copying down the rest, my new expression is 1 plus 10. All right, let's finish evaluating this expression with the remaining addition. 1 plus 10 is 11. So the final height, 11 feet. Jake's tree will reach 11 feet after 5 years. Great work. Let's practice substituting a value for a variable into an expression, and then using the order of operations to evaluate an expression together in 3 example problems. This example problem asks us to evaluate 3 times the sum of m and 2 minus 1, when m equals 6. Pause the video and try this in your PDF. First, use substitution. Remember, one player comes out and another player comes in to replace them. Then, evaluate using the order of operations to find the expression's value, or what it's equal to. Go ahead, give it a go. Okay, let's work this through. Well, since we know m equals 6, we can substitute that into our expression. So m will come out and 6 will come in. I'm going to rewrite our expression below to show that substitution, leaving us with 3 times the sum of 6 plus 2 minus 1. Now we are ready to evaluate, or find this expression's value using the order of operations. We start by working on anything in a grouping symbol. In this case, only 6 plus 2 is grouped together. 6 plus 2 gives us 8, so our new expression becomes 3 times 8 minus 1. Next, there are no exponents for us to evaluate, so we move on to multiplication and division. Here we have 3 times 8, which gives us 24. Now our expression is 24 minus 1. The only operation left is the subtraction here, 24 minus 1, which leaves us with 23. This problem didn't have any real-world context, so it has no units. This means our final answer is just the number 23. Our next example problem asks us to evaluate 5 plus 2 times the sum of 4a squared plus 9 when a equals 3. Let's first have a look at this term, 4a squared. Here, 4 is the coefficient of a squared, which means that there is multiplication between them. So really, this is 4 times a squared, where only the a is being squared in this term. Okay, now that we've had a good look at this expression, pause the video here and substitute the given value of a into the expression. After substituting the given value of a into the expression, we are left with 5 plus 2 times this whole thing, 4 times 3 squared plus 9. Notice the parentheses around 3, they show that only the 3 is being squared, and they show multiplication between 4 and 3 squared. Now let's evaluate using the order of operations. We start with the expression within the grouping symbol, these parentheses here that are grouping these terms together. But there are multiple operations inside this grouping, so how do I handle them? There's exponent work with 3 squared, multiplication between 4 and 3 squared, and the addition of 9. When multiple operations exist within a grouping symbol, then we just need to follow the order of operations again. So the first operation within this grouping would be the exponent, 3 to the power of 2. Exponents, also called powers, tell me how many times to multiply the number by itself. So in this case, we need to multiply 3 by itself 2 times, which would be 3 times 3, giving me 9. After exponents, we work on multiplication and division. So 4 times 9 gives us 36. And lastly, we do subtraction and addition. So 36 plus 9, which gives us 45. Now, with the grouping symbols resolved, our expression becomes 5 plus 2 times 45. Again, to decide which operation to do first, we look to the order of operations. This expression no longer has grouping symbols, only parentheses showing multiplication. There are no exponents. So next is multiplication and division. So we'll do 2 times 45, which gives us 90. All that's left is 5 plus 90, which equals 95. This problem didn't have any real-world context. It had no units, so our final answer is just 95. Our final example problem asks to evaluate 10 minus 2 times the sum of 1 plus x divided by 3 when x equals negative 15. Pause the video now and try substituting the value of x into the expression, and then use the order of operations to evaluate it. After substituting negative 15 for x, my expression is now 10 minus 2 times the sum of 1 plus negative 15 divided by 3. Considering the order of operations, what would be the first step to evaluate this expression? Exactly. We start within the grouping symbols, which is this part of the expression here. We have addition here, but we also have division. Which one do you think we should do first? Yes, division comes first. Negative 15 divided by 3 gives us negative 5. But it's bad math grammar to have two signs or operations next to each other, so I can rewrite 1 plus negative 5 as just 1 minus 5. Now I will do 1 minus 5 to finish up with work within my grouping symbols to get negative 4. Now what's next? Well, let's check the order of operations. There are no grouping symbols, no exponents, but there is multiplication. However, there are two ways to think about this multiplication, and both are correct. One way is to view this as 10 minus 2 times negative 4, which would give us 10 minus negative 8. Again, to avoid two operations together, we will rewrite this as 10 plus 8, since two negatives make a positive. Now, another way that we can think about this multiplication is as negative 2 times negative 4. And that gives us a positive 8, which would then give us 10 plus 8. As you can see, plus and minus symbols can represent operations like addition and subtraction, or signs like positive or negative signs. As you practice, you'll find out which interpretation works best for you. And both are correct, since both lead to 10 plus 8. Whenever we evaluate, we should get a single number, so we need to finish this up by adding 10 plus 8 to get a final answer of 18. Great work! In this lesson, we learned how to use substitution to evaluate algebraic expressions. With substitution, we replace a given number for the unknown variable in an expression, which allows us to then evaluate or find the value of that expression. After watching this video and completing your guided notes, continue practicing substitution and the evaluation of algebraic expressions by completing the additional practice problems in your PDF. Mastering the order of operations might seem tough initially, but I assure you, with practice, it will become second nature. Once you're ready, tackle the practice game, and I'll see you next time. Hey.